Let's review some of the reactions we learned about in this chapter by looking at some of these examples. In the first reaction, we're going to take an organolithium and add CO2 followed by aqueous acid. In the second reaction, we're going to use a nitrile and we're going to add sodium hydroxide, water, and heat, which are basic hydrolysis conditions, followed by aqueous acid. Or we can add sulfuric acid, water, and heat. If we start off with a primary alcohol or an aldehyde, we can do an oxidation reaction with chromic acid, and that could involve either chromium trioxide or sodium dichromate. If we have a benzene compound that has an alkyl group, we can oxidize this compound with chromic acid as well. Note that we can also do this reaction with potassium permanganate. In the last reaction here, we're going to take an alkyl halide and we're going to add sodium cyanide. Adding CO2 to an organolithium or even a Grignard reagent will lead to adding a carboxylic acid to the carbon where the metal is. By adding aqueous acid in the second step, we will make sure that the oxygen is protonated, giving us the carboxylic acid. If we take a nitrile and we add sodium hydroxide, water, and heat, we will hydrolyze this nitrile into the conjugate base of a carboxylic acid. So that means this product here, minus the hydrogen with a negative charge on the oxygen, will be produced. So this results from the fact that the reaction is done under basic conditions. If we add aqueous acid, the conjugate base of this compound will be converted into the carboxylic acid you see here. We can do the same reaction just by simply using sulfuric acid, water, and heat, and so a nitrile will be hydrolyzed to this carboxylic acid. So note that whenever we do reactions with or that produce a carboxylic acid under basic conditions, and so we saw that with the first reaction on top and at least the first part of this reaction. By doing it under basic conditions, we always first obtain the conjugate base of a carboxylic acid, so we have to use a second step in both reactions to convert it to a carboxylic acid. Doing it under acidic conditions skips that step, and so we simply just go from the reactant to the carboxylic acid. With a primary alcohol or an aldehyde, we can oxidize it with chromic acid to convert it into the corresponding carboxylic acid. Notice both the aldehyde and the alcohol contain 3 carbons, so the product here will also contain 3 carbons. Whenever we have an aromatic compound with a side group, an alkyl group, that has at least one benzylic hydrogen, so in this case there is 1 hydrogen right here, that allows for the entire group, the alkyl group, to be converted into a carboxylic acid. And it doesn't matter that it is an isopropyl group, it could be a methyl group, it could be an ethyl group, just a straight propyl group, butyl group, anything that has benzylic hydrogens can be converted into a carboxylic acid. In the last reaction here, we have an alkyl halide. If we add sodium cyanide, the cyano group will attack the carbon where the leaving group is and replace it. Since this is an SN2 reaction, it works best when it's a primary alkyl halide or even a secondary one. In the first reaction in this slide, we're using a nitrile and we're doing a hydrogenation. The next reaction involves a nitrile reacting with thiol followed by aqueous acid. The next reaction is a nitrile reacting with lithium aluminum hydride followed by aqueous acid. And then lastly, we're using a nitrile reacting with an organolithium or a Grignard followed by aqueous acid. We start off with a nitrile and we do hydrogenation. So usually for nitriles, it will be done with nickel and high pressure hydrogen, we can reduce the nitrile into a primary amine. Notice the amine will have the same number of carbons as the nitrile. If we take a nitrile and we add diol followed by aqueous acid, the carbon here where the nitrile is will be converted into an aldehyde. Although not shown in this example, we typically will also have a byproduct of ammonia, which is NH3. In the next reaction, we're starting off with a nitrile. If we add lithium aluminum hydride, we're going to reduce the nitrile similar to the hydrogenation reaction into a primary amine. And then lastly, if we take a nitrile and add a lithium reagent or a Grignard reagent, these carbanions will be transferred to the carbon of the nitrile. So in this case, we're adding a methyl group. And then the carbon to nitrogen triple bond will eventually be converted into a ketone as shown in the product. Notice the ketone has a methyl group on the right side. The left side is the same carbon chain that we see with the nitrile. Note that the carbon here that is part of the nitrile will be the carbon that is part of the ketone in the product. To finish this chapter, let's do a synthesis problem. So we're starting off with a primary alcohol, and we're converted into a carboxylic acid. Notice that the carboxylic acid has one more carbon compared to the alcohol that we're starting with. In this case, we can answer this question. So one of the things we want to do though is first convert this alcohol into a good leaving group so that we can do substitution reactions. So for example, we can convert this alcohol into a tosylate by adding tosyl chloride and pyridine, which is a base. That will convert this alcohol into the tosylate that you see here. Remember, tosylates are similar to alkyl halides, so we can do substitution reactions. So for example, we'd add sodium cyanide, which will replace the tosylate group with a cyano group, as shown here. And then the nitrile can be hydrolyzed either under basic or acidic conditions. I chose to use the acidic conditions since they're usually simpler. And so the nitrile we converted into this carboxylic acid. Another way that we can make this synthesis complete is by converting the alcohol into an alkyl halide. So we could use PBr3, for example, to convert it into this bromide, or we could use sodium bromide to replace the tosylate in this compound into a bromide. And then the alkyl halide can be converted into a Grignard or an organolithium by adding magnesium or lithium. And then that turns these compounds into carbanions, which are nucleophilic, and they can react with CO2 to add a carboxylic acid. Note in this reaction, not only did we transform the alcohol into a carboxylic acid, but we also added an extra carbon, which we can do by adding the cyanide nucleophile if we go this route, or by adding CO2 by going through the Grignard or organolithium route.